Now students, we see the nth term of an AP. Let we know an AP, the first term is A, the second term A plus D, third term A plus 2D, and fourth term A plus 3D, and so on. This is an AP. Here first term T1 is A, T2 is A plus D, T3 is A plus 2D, T4 is A plus 3D, and so on. If we observe that, we get here the coefficient of 2, D is, and the term here 2, the at here in term 2, A plus 2 minus 1D. Here 3 minus 1, which get 2. Here A plus 3 minus 2D. At here A T4 is equal to A plus 3D. That means A plus, we write this as it is 4 minus 1 into D, and so on. If we get Tn term, that is A plus n minus 1D. This is our formula, that is the coefficient of D is less than 1 of that nth term. And Tn is equal to A plus n minus 1 into D. That is our Tn term. If A is the first term and D is the common difference, then we get the Tnth term, which is by the formula A plus n minus 1 into D. Now we see some examples on it. In this example, given arithmetic progression AP 12, 16, 20, 24, and so on, find the 24th term of this progression. That means here the sequence AP is given. AP is 12, 16, 20, 24, and so on. Hence the first term A is equal to 12 and D is equal to the difference between two consecutive terms 16 minus 12, which is 4, and hence our Tn is equal to A plus n minus 1 into D. Substitute the values of A and D at here. We get Tn is equal to A is equal to 12 plus n, we doesn't know n, and D is equal to 4. Hence we get Tn is equal to 12 plus n minus 1 into 4. You have to multiply this by to the bracket. We get 4 into n, 4n, and 4 into 1, that is minus 4. Hence Tn is equal to 12 minus 4, which is 8 plus 4n. Hence we get Tn. Now we have to find the T24 term, that is T24 is equal to 8 plus 4 into bracket 24, that is get 8 plus 4 into 24, hence 8 plus 4 into 24 is 96, hence plus 8 plus 96 is 104. Hence T24 is equal to 104. We can substitute this nth value at here also, and we find the T4 is equal to T24 is equal to 104. That is the 24th term. Now we see the fourth example in 3.2. Find the 19th term of an AP. It's given 7, 13, 19 and 25. Here an AP is given 7, 13, 19, 25 and so on. That means A is first term, which is 7, and T is the difference between two consecutive terms, 13 minus 7, which is 6. And we have to find T19, that is the 19th term, that means we have to find T19. Our formula is Tn is equal to A plus n minus 1 into T. Substitute this value at here. T19, that means n is equal to 19 is given, and T19 is equal to A is 7 plus n is 19 minus 1 into D is 6. Hence our solution we get 7 plus 19 minus 1 is 18 into 6. And 7 plus 18 into 6 is 108. Therefore 7. Now we see 6, 7th and 8th, 3 problems in 3.2. In 6th problem, find how many 3-digit natural numbers are divisible by 5. That means we have to find the numbers which are divisible by 5, 3-digit numbers. Now we solve this example. 6th example. The 3-digit number start from 100, 101 and so on. Last 3-digit number is 999. Now the number which is divisible by 5, the first number which is divisible by 5, the 3-digit numbers which are divisible by 5, the first number is 100, second 105, 110 and so on. The last number is not 999, which is 995. And then the 5 divisible by 5 is 1000, which is not a 3-digit number. Okay, that means last number is 995, which is last 3-digit number, which is divisible by 5. Hence we get, this is A, the first number is 100, the difference D, common difference D is 5, and the last number, that is Tn, is 9, 9 and 5, and we have to find n, how many numbers are there which is divisible by 5. Our formula is Tn is equal to A plus n minus 1 into D. Substitute this value at here, we get 995 is equal to 100 plus n minus 1 into D. D is 5. Multiply this, we get 100 plus 5n minus 5 is equal to 995. 100 minus 5 is 95. Hence 995 is equal to 95 plus 5n. Take 95 to the another side, we get 995 minus 95 is equal to 5n. With subtraction we get 900 is equal to 5n. Take the 5 to another side, 900 upon 5 is equal to n. Hence n is equal to 900 upon 5, which is 180. And hence there are 180 numbers which are three-digit numbers which are divisible by 5. That is our final answer. Now see the next one, 7th problem. In 7th, the 11th term and the 21st term of an AP are 16 and 29 respectively. Then find the 41st term of that AP. In this problem, the 11th term, that is T11, is given and T21 is given. T11 is 16 and T21 is 29 is given, and we have to find T41. Now we solve this problem. In this problem, T11 is given, T11 is 16, T21 is also given, that is 29, and we have to find T41. For this, we have to first find A and D. Now we know that formula Tn is equal to A plus n minus 1D. Substitute here, T11 is equal to A plus n is equal to 11, that means 11 minus 1 into D. Hence T11 is 16, therefore 16 is equal to A plus 10D. Hence A plus 10D, I write this first, is equal to 16, that is equation number 1. This equation is in term of simultaneous equation. Similarly, we get the second simultaneous equation by equation by T is equal to T21 is equal to A plus 21 minus 1 into D by this formula. T21 is 29 is equal to A plus 20D, and hence our second equation become A plus 20D is equal to 29, that is equation number 2. Here the coefficient of A are the same, that means we have to subtract these two equations. We get subtract equation 1 from 2. Equation 1 from 2. Equation 2 is, we write equation 2 first, A plus 20D is equal to 29, that is equation 2, and equation 1 is A plus 10D is equal to 16. A plus 10D is equal to 16. That is equation number 1. We have to subtract this, that means first change the sign. A get cancelled, hence 10D is equal to 29 minus 16, which is 13, and hence D is equal to 13 upon 10, that means 1 upon 1.3. Now substitute this value, d is equal to 1.3. Substitute this value in any equations 1 or 2. In equation 1, we get a plus 10d is equal to 16. Hence a plus 10 into 1.3 is equal to 16. The multiplication we get a plus 13. We have to take the decimal up next to 3 is equal to 16. Take 13 to the another side. A is equal to 16 minus 13. A is equal to 3. A is equal to 3. Hence we get the values of A and D. Now we can find T41. Now Tn is equal to A plus n minus 1 into D. Therefore T41 is equal to A is 3 plus n is 41 minus 1 into D is 1.3. And hence we get T41 is equal to 3 plus 41 minus 1 is 40 into 1.3. Hence 3 plus 40 into 1.3, 13 fourths are 52.0. And hence we get T41 is 55. Our final answer is the 41 term is 55. Now we see the last example, which is 8th example. In this 8th example, 11852 dash 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 in this AP, which term is minus 151? Or to the term which is 151, minus 151. That is Tn is given, A is given, D is given, and Tn is given. We have to find n. Which term? That means we have to find n. Now we solve this example. In this example, AP is given 11, 8, 5, 2 dash dash dash. Hence A is equal to 11, D is equal to 8 minus 11, the difference between two consecutive terms, which is minus 3, and D is equal to minus 3, and Tn is given, Tn is minus 151. They have to find which term is minus 151. That is Tn is given. We have to find n is equal to what? Find n is equal to what? And hence by our formula, Tn is equal to A plus n minus 1 into D. Minus 151 is equal to 11 plus n minus 1, we doesn't know n, into D is minus 3. Hence minus 151 is equal to 11, and we have to multiply this. Minus 3 into n is minus 3n, and minus 3 into minus 1 is plus 3. And hence minus 151 is equal to 14 minus 3n. Take minus 3n to the another side and minus 141 to the next side. Hence we get 3n is equal to 14 plus 151. Hence 3n is equal to 14 plus 151 is equal to 1, 4 and 5, 4 and 1, 5, 6 and 1, 165. Take 3 to the another side. Hence n is equal to 165 upon 3. Therefore n is equal to 3 5s are 15, 1 remaining, 1 plus 1 15, 3 5s are 15, hence n is equal to 55. That means our answer is 55th term of this AP is minus 151. Now we solve the remaining examples in 3.2, and next part is in another video.